Hello, dear colleagues, dear students. Welcome to another session. And we are going to continue with our challenge in covering mathematics here so that we discover whether Tanzanian students specifically are going to understand mathematics through YouTube channel like this channel here. If it is your first time to be here, consider subscribing to the channel so that you are going to be updated on the coming content. So we're going to dive into today's part. In the previous sessions, our discussion was on laws of exponents. And one of the part we have already actually discussed is the product rule. And the product rule, just to summarize it, product rule, to summarize it, consider when you are given exponents with the same base. So when you have exponents with the same base, what we do, we just add the exponents, and that is actually multiplication. So the summary of what we discussed last time is here, and we say that whenever you are given exponents with the same base, and in our case here we have base A, so multiplication of these exponents, you just add the exponents. But also on the process, we have seen how power rule can be applied, and this is when actually you have exponent raised to another exponent. And so to evaluate that type of exponents, this is actually just like multiplying these two exponents. And so today we are going to dive now into another law of exponents, and that is division law of exponents. Now consider the following example of dividing exponential numbers in the same base such that we have 7 power 1 divided by 7 power 3. I will change this one to be actually 7 power 5 here, because I want to get the positive number first. Okay. By the way, it was 7 power 5. So the way we do this question, of course, here it was 3. An apology, it was only typing error. So to understand the way we are doing this question, first of all, you are going to expand it the way it is. And so you are going to consider if you have 7 power 5, that is actually 7 being multiplied 5 times. And then divide by 7 power 3. So you'll be dividing by 7 being multiplied 3 times. And eventually when you do that, you're going to see that 7 and 7 will be going. 7, 7 goes, 7, 7 goes, eventually remains 7 times 7, which is 7 square. So from this example we have seen here, in this example, the exponent 2 can also be obtained by subtracting the exponential of the denominator from the exponents. We subtract the exponent of the denominator from the exponents of the numerator while retaining the same bases. And actually in that case, you'll be seeing that we are simply taking 7 power 5 minus 3, which will be 7 square. Okay. We can have another example. This is actually a power 1, 2, 3, 4, 5, 6, 7. This is a power 7 here over a power 4. So you're going to expand the a power 7. So a will be multiplied by 7 times, divided by a being multiplied 4 times. And eventually you'll be getting actually a times a times a, which is actually equivalent to taking a power 7 minus 4, and you're going to come out with 7 a power 3. So, dear students, generally, when dividing exponential numbers of the same base, understand that the most important part here is same base. So when dividing exponential numbers of the same base, you simply subtract the exponent of the divisor from exponent of dividend. And in this case, actually, you have seen that xc power m over xc power n is eventually xc power m minus n. This is n, of course. We are not expecting, of course, xc to be 0, as otherwise this is going to be meaningless. Having 0 over 0, obviously you are going to have undefined expression. Let us go to example. Simplify the following expressions. So to simplify this, we simply take 3 power 20 minus 12 according to laws of exponents, and this is going to be 3 power 8. Okay? Coming to this is going to be a power 28 minus 17. This is going to be a power 11. Coming to this is actually 19 here. So this is going to be equal to 0.47 power 19 minus 17, and eventually we get in actually 0.47 power 2, dear students. So we have seen actually how we divide exponents. Similarly, when exponential numbers of different bases with the same exponents are divided, now we are reversing now. We don't have actually the same bases, but we have different bases. The same exponent actually there. So the number can be expressed as single exponents. And this is the case when you have a power 4 over b power 4. When you open this, eventually you'll be having a over b power 4, dear students. So you can have this as a rule, of course, and it is actually a very important rule that having xc power n over y power n, we can actually summarize it to be x over y power n, dear students. Let us proceed with the next part. So we go to example number 2. In example number 2, I'll write each of the following expression in the form of x over y power n. So we have different bases, but the same exponents. So this is going to be written as 13 over 9 square. And this one here will be 0.5 over 0.3 power 4. And the next one, we have actually 16 over 3 square. We can rewrite it again. We have 16 over 3 square. This can be written as 4 square over 3 square. So the same exponent, so it is 4 over 3 square, dear students. We proceed to example number 3. Simplify each of the following expressions. You can actually pause the video here and you go back to simplification, then come back when you're done with simplification. So to simplify this, before going to this, I just want to show you, because that was a problem actually. I didn't show you the way we solved this, but from here you can see that we have the same exponents but different bases, and we have expressed them in this form here as are required. So this is how it is. The second one was here, and the third one is here also, 4/3 square. And now we are going to jump to example 3. Simplify each of the following expressions. So with this, we'll be taking x power 5 minus 2. We used actually laws of division, so that is x power 3. Coming to this, it will be 10 power 7 minus 4. We'll be having actually 10 power 3. Coming to this, you have 2 power 7,000 minus 6,998. Eventually we'll be having actually 2 power 2, which is 2 square. So that is simplification, dear students. You can go to further simplifications. Actually, we have so many examples here in your handout. As I said, I'm going to upload this, of course, in the cloud, so that you can see these questions. And now I'm going to jump to the last rule. We have discussed the product rule. We have also discussed the division rule, and then now we are coming to zero exponents. In this expression here, 7 power 1, this is actually meant to be 7 power 1, an apology for misunderstanding, but this is meant to be 7 power 1. So if I have to write 7 power 1 over 7 power 1 over 7 power 1, this is actually having a number, an apology. This is 7 power 3, power 3. So this is 7. We have 7 power 3. You divide it by 7 power 3. So from this expression, 7 power 3 over 7 power 3, so this is meant to be 3. So 7 power 3 over 7 power 3 is similar to taking 7 times 7 times 7 over 7 times 7 times 7, which is actually equal to 1. So alternatively, 7 power 3 over 7 power 3, this is actually 7 power 3 minus 3, which is 7 power 0, and eventually we are getting 1. So we are going to generalize actually. So if you have any number raised to power 0, eventually you are going to get actually 1. But 0 is actually, x is not equal to 0. Make sure that you don't have actually 0 power 0. 0 power 0, this is undefined. 0 power 0, that is actually something undefined. So to summarize, after all these discussions, I think you are in position to remember these rules. The first rule, we said we have product rule, and this is when we have two exponents with the same base being multiplied, and you simply actually add the exponents. So having a exponent m times a exponent n, you add the exponents, and the answer is actually a power m plus n. You go to division rule, dividing exponents with the same base but different exponents. So you simply actually subtract the exponents of divisor from exponents of dividend, and there you are. And going to power rule, we have seen actually while we were proving the product rule, that you have exponents raised to another exponent, you simply actually multiply those two exponents to get the simplified part. Zero rule, a power 0 equals to 1. A is all real numbers, but a is never 0 also, of course, because having power a 0 power 0, that is something different, and that is the case when you have now undefined expression. Okay, that is all, dear colleagues, regarding exponents. Before we come to the end of the session, I'd like to highlight another important information. It is not actually a new rule, just to give you idea of the discussion here. Let us see negative exponents. Let us see negative exponents. From this expression, 8 power 3 over 80 power 5, this expression can be simplified as we have seen here, that 8 power 3 is eventually 8 times 8 times 8, divided by 8 power 5. So you get actually, you get 8 being multiplied 5 times, and the feedback here you'll be getting actually 1 over 8 square. Okay, but don't forget the exponents rule. So if I have to consider this as case number 1, but you remember the exponents rule, that 8 power 3 over 8 power 5, this is actually 8 power 2. This is 2, of course, an apology. Also, we have 8 power 3 over 8 power 5. By using exponents rule, this is going to be 8 power negative 2. So actually 8 power negative 2, this is the same as having 1 power 1 over 8 square. It is actually reciprocal rule. So by comparing these two equations, this is equation 1 and this is equation 2, it shows that we can see that 8 power negative 2, here is negative 2, is equal to 1 over 8 square, of course. Similarly, having k power 5 over k power 8, this is 8 here. When you simplify, you'll be getting 1 over k power 3. And by using exponents rule, quotient rule, division rule, you'll be having actually k power 5 minus 8, which is going to be k power negative 3. So you can compare, of course, k power negative 3, this is equal to 1 over k power 3. Okay? So these are the details actually regarding negative exponents. So actually you have to be in position to understand the concept of negative exponents. And that's why we say that k power 3 over k power 5, this is 1 over k, an apology, just comparison of what we discussed above, actually k power 5 over k power 8. So one of them is 5, the other one is 8, and eventually you have 1 over k power 3 which is k power negative 3. So in general, if x is not 0, x power negative n equals to 1 over x power n, where n equals to 1. When n equals to 1, this is when you have x power negative 1 equals to 1 over x. I think these are very important details. Make sure that you are not forgetting them. Can we see the last case examples before we end up the discussion? Express the following exponential numbers using positive exponents. So this is the same as 1 over 4 power 3. This is the same as 1 over a power 7. This is the same as a 1 over 19 square. We just reciprocated them, of course, to get the positive exponents. Going to example 2, simplify the following expression and give your answer in positive exponents. So when you simplify here actually is x power 3 minus 9, it is x power negative 6, which is 1 over x power 6, because we are supposed to give our answer in positive exponents. Coming to this, you check actually like exponent with the same basis. So it is this is going to be equal to a power 4 minus 16, b power 17 minus 11. And this is going to be equal to a power negative 12 times b power 60. Because we are supposed to see only negative positive exponents. So this is actually b power 60 over a power 12. Okay. And now the last part. Simplify the following expression and give your answers in negative exponents. So we just have used the laws of exponents, and this is actually 3 power 9 minus 16. It will be actually 3 power negative 7. What about this? We have 0.7 power 60 minus 3, which is 0.7 power 3, and it is equivalent to 1 over 0.7 power negative 3. Okay. So that is all regarding laws of exponents. We have already covered all laws and we have seen the summary of them. It is actually upon you to solve all these questions. All of them, they are very basic questions. Don't forget to go through them. You can spend a very few minutes actually to finish all the questions. And that is all regarding laws of exponents. So to give you a summary again, we talked about the product rule. And this is when we have the same base, exponent with the same base being multiplied. So we just add their exponents. Quotient rule or division rule, you have actually exponents of the same base being divided. You just subtract their exponents. Coming to power rule, we have actually exponent raised to another power, so you just multiply the exponents. Zero exponents, this is when you have any non-zero number raised to power of 0, and actually the answer is going to be equal to 1. And negative exponents, we are just talking of reciprocals. So b power negative 1 is going to be 1 over b power n. So this is a summary of the entire 3 lectures we covered up to this point, dear students. We are going to end up here. I urge all of you to do as many questions as possible so that you're going to be stable in the way we are doing the questions. Mathematics without solving the questions is a challenge. You cannot actually master the concepts without solving the questions. So solve as many questions as possible. And in the description part, I shared the link for the WhatsApp group and WhatsApp channel. We are building the community there so that later on we are going to have wonderful sessions, of course, on this channel and other platform which can connect you very easily with us. I wish you all the best as you prepare actually to start your new year, new term. First of all, Happy New Year to all of you, but have nice preparation as you prepare to start your school next week. See you in the next session.